Let's look at several molecules and see if we can predict their relative boiling or condensation points. Here's three molecules, H2O, H2S, or NH3. Which among them is going to have the highest boiling point? Think about that for a minute and make a selection. Let's look at possible explanations for each of the answers. A, H2O has the largest bond dipoles, so it forms the strongest hydrogen bonds. B, all have hydrogen bonding, but H2S is the most massive, so it'll have the highest boiling point. Or C, NH3 has more hydrogens, so it can form more hydrogen bonds, and it will have the highest boiling point. Think about those three possible explanations and make a selection. We're trying to determine the relative boiling points of H2O water, H2S hydrogen sulfide, and NH3 ammonia. And we do that by determining the relative strength of the intermolecular interaction. Now, all these particles have the three classic intermolecular interactions. Dispersion forces, they have dipole-dipole interactions, and hydrogen bonding. Whenever hydrogen bonding is involved, though, that's the dominant force. It's orders of magnitude greater than the other two forces. So what we have to determine is which of these has the strongest hydrogen bonding interaction. The strongest hydrogen bonding interaction will come from the greatest dipole. So is the OH bond, the SH bond, or the NH bond the greatest dipole moment? Well, we determine that by the difference in electronegativity. You know, O is more electronegative than S is more electronegative than N, nitrogen. So the most electronegative element, oxygen, creates the greatest dipole on the intramolecular bond. OH bond in water has a great dipole moment larger than the SH bond in the hydrogen sulfide, which is greater than the NH bond dipole in ammonia. So oxygen will have the most negative charge and the most ability to attract a positively charged oxygen on an adjoining molecule. Sulfur slightly smaller, and the NH bond slightly smaller yet. So the greatest dipole-dipole gives the greatest hydrogen bonding interaction, and in that case, that's water. So among these three, the highest boiling point is the one with the strongest intermolecular interaction. Remember, the intermolecular interaction has to be overcome by kinetic energy to boil. Higher kinetic energy, higher temperature. So more intermolecular interactions that are very strong means higher temperature to boil. So in this case, water is the largest intermolecular interaction, largest hydrogen bonding interaction, and that's the correct answer. And in fact, this is reflected in the van der Waals A parameters for these three molecules. Water, 5.46, is bigger than hydrogen sulfide, 4.84, and that's larger than the A parameter in ammonia, 4.17. So we have the hydrogen bonding interactions reflected in the boiling points and the size of the van der Waals A parameters.